Geologists have discovered something odd at Yellowstone National Park that they say is an important sign of what could happen when the supervolcano erupts. So, what exactly happened? Well, to understand what this new discovery means for Yellowstone, we need to start with what makes Yellowstone so special in the first place. Yellowstone is home to one of the largest and most powerful volcanoes on Earth. And this volcano isn't just one single peak, but is actually a supervolcano formed by 3 major eruptions in the past 2 million years. Its magma chamber sits about 6 miles beneath the park and stretches out for roughly 43 miles from north to south and 28 miles from east to west. Now these dimensions are bananas. In fact, its magma chamber is so large it's been given its own name, the Yellowstone caldera. But while we're all familiar with volcanoes shaped like cones, the magma chamber beneath Yellowstone is actually shaped more like a giant dumbbell or 2 connected dumbbells. And we can thank the shape of the magma chamber for some of the strange activity we see at the park. You see, Yellowstone is also home to more than 10,000 geothermal features, including the world's largest concentration of geysers. These features are powered by steam coming from the magma chamber below, which is kept warm by the hot rock found deep within the Earth's mantle. And because the magma chamber is shaped like a dumbbell, the steam rises to the surface in relatively predictable places. In fact, we can actually use the predictability of these features to help us understand how the magma chamber below is changing over time. That's why in 2012, the Yellowstone Volcano Observatory began monitoring subtle changes in the park's geothermal features. By measuring things like the temperature of the water and the frequency of eruptions, researchers hope to learn more about what's going on beneath the surface. And it was through this research that scientists noticed that something had changed. They found that between 2012 and 2018, the intervals between eruptions at several geysers changed. Now there are several different types of geysers, and the way they erupt varies accordingly. For instance, at the Norris Geyser Basin, the interval between eruptions is relatively consistent. Here the pressure from the steam builds until it reaches a critical point, and then the geyser erupts before the pressure has a chance to build up again. But there are other types of geysers, like the Black Sand Basin, where the intervals between eruptions are less consistent. With these geysers, the pressure from the steam builds up, and then instead of reaching a critical point, the pressure is abruptly released due to some unknown factor like an earthquake. Now what's interesting is that the geysers that saw a change in eruption interval were of the second type, the ones that are more sensitive to external factors like earthquakes. Between 2012 and 2018, scientists observed an increase in the frequency of eruptions at several of these geysers, and to them, this hinted at movement in the magma chamber below. You see, if there's any movement of the magma itself, or even just the hot rock surrounding the magma, known as the magma's country rock, that movement can cause small earthquakes, and those earthquakes can be the external factor needed to trigger an eruption. So based on the increase in eruption frequency, it appeared as though the magma chamber was becoming more active, potentially getting ready to erupt. But to confirm this, researchers needed to look for evidence of increased seismicity, that is, more earthquakes. Luckily, they didn't need to look far. Just a few months after they published their study on the geysers, they got their answer. A local resident reported feeling an earthquake at their home near Yellowstone, and when the team checked the data, they found that it was only the tip of the iceberg. They discovered that between 2018 and 2020, there were hundreds of earthquakes beneath Yellowstone. Most of these quakes were too weak to be felt by humans, but some were big enough to make headlines. In total, there were 1744 earthquakes, with a magnitude of at least 3.0, which is the threshold at which people generally begin to feel them. This swarm of earthquakes was the largest ever recorded in the Yellowstone region. And to put it in perspective, the previous record for earthquakes in the area was set in 1985, when there were 3,000 earthquakes over a period of 6 days. The recent swarm, on the other hand, occurred over a period of 2 years. All of this seismic activity was centered around the northern part of Yellowstone, right near the town of Gardner, Montana. And this is important because it gives scientists a clue as to where the magma chamber might be located. See, when magma moves around, it causes the surrounding rock to move and shift, which in turn causes earthquakes. So by looking at where the earthquakes are happening, scientists can get an idea of what's happening with the magma. In this case, the earthquakes were mostly concentrated along a fault line running northwest to southeast through the park. Now, faults are fractures in the crust, and this particular fault, the normal fault, is associated with areas of extension. Faults like these often occur when tectonic plates are moving apart, and in the case of Yellowstone, this is exactly what's happening. The North American plate is moving to the southwest, while the Pacific plate is moving to the northwest. As they pull away from each other, the rock between them is pushed upward, forming mountain ranges like the Rockies. But not all the rock is created equal. Some of it will simply be pushed upward, while other weaker sections will slip downward along faults, like the normal fault. And while it might seem counterintuitive, the downward slipping of rock actually creates space for magma to rise into. So based on the location of the earthquakes, it appears as though the magma chamber is situated along the normal fault in an area known as the northern magma plume. And that's great news for scientists. You see, until now, the exact location of the magma chamber was a bit of a mystery. The 2018 location of the earthquakes gave them an upper bound for where the magma chamber might be, but they still weren't sure exactly where it extended to. There was a gap of about 25 miles between the northernmost earthquakes and the northern edge of Yellowstone. So the team wasn't sure whether or not the magma chamber extended under the entire park or stopped short somewhere in between. But with this new evidence of earthquakes happening right in the middle of the park, it looks like the magma chamber extends further north than anyone thought possible. So, what does this mean for Yellowstone? Well, knowing the precise location of the magma chamber helps scientists better understand how it's evolving over time. To do this, they use a technique called continuous GPS monitoring, which allows them to measure even the tiniest movements in the ground, like a few millimeters. With this data, they're able to create models of how the magma chamber is moving and growing, and ultimately, that tells them whether or not an eruption might be imminent. Now don't worry, they won't miss the signs if an eruption is on the horizon. After all, there are plenty of warning signs to watch out for. First, there would be increased earthquake activity, similar to what we saw in 2018 and 2020. Next, the ground would start to bulge upward as magma made its way toward the surface. And finally, gas emissions would increase as pressure built up inside the magma chamber. At this point, officials would likely issue an alert and park visitors would need to evacuate immediately. Luckily, there are no signs of an eruption at the moment. In fact, things are relatively quiet at Yellowstone, which is good news for the thousands of tourists who visit the park each year. But that doesn't mean it will stay that way forever. Eruptions are a natural part of Yellowstone's history, and it's only a matter of time until it erupts again. When it does, it will likely look very different from previous eruptions as the magma chamber has evolved over time. In fact, scientists believe the next eruption will likely take the form of an eruption column rather than a lava flow. An eruption column is a tall cloud of ash and pumice that forms over the volcano. This is different from a lava flow in that it's much more explosive. In a sense, you could think of it like a volcanic tsunami. The magma erupts out of the ground and then collapses, causing a cloud of debris to shoot high into the atmosphere. If this happens at Yellowstone, it could send ash and pumice raining down over a large portion of the western United States. It could also block sunlight and cause global temperatures to plummet. But before we all retreat into our bunkers, let me reassure you that scientists are still a long way from predicting when this will happen. All we know for sure is that it will happen again. And when it does, it'll likely look nothing like what we've seen in the past. Thanks for watching this episode of SciShow, and thanks to one of our patrons for asking this question. Our patrons could submit questions to our inbox, and our editors pick out the best ones to answer in episodes like this one. Do you want to be one of those people? You can find out how to support us at our website.